Unga chaka, unga chaka, ooh. Unga chaka, ah. And we are live, ladies and gentlemen. Welcome back to the Dev Ed channel. Here we are. We are gonna learn everything about TypeScript and more. Absolutely fascinating. TypeScript mentioned, who summoned you? I summoned you. Here we are. Hi from Twitch. I see you. I see people from everywhere. All right. So here's what we're gonna do today. We're gonna practice our fingers, our typing skills. We're still gonna try hard to achieve 150 words per minute. That's the goal. By the end of this year, we'll match the speed. And you guys also send me a list. So let me pull the list up. This is the list that you guys from chat told me. LS, not KS for kill myself. LS. And I have a keyboard here. So if I do env keyboards and we check, these are the 5 that got recommended. So by the end of the stream, we'll pick one, we'll purchase it, we'll unbox it on stream. It'll be a good time. And then we'll see if our speeds have improved. Okay. Hello, everyone. Good to see ya. Hello from Somalia. Hello. Okay, so let's close this up. Bye. I've been typing off stream quite a bit. I'm trying to get a bit of practice in, at least half an hour every day. I get on monkey type and I type. And I feel like I'm slowly improving, which is fantastic. So let's do a little warm up. And then what we're gonna do next is we are gonna go through the entire TypeScript documentation. That's what we're gonna do line by line. We're gonna learn absolutely everything that we need to learn until I finish the whole docs. That's what we're gonna do. Thank you for following. Really appreciate that. So we're gonna start from scratch. Yeah, it's gonna be a very good time. So we're probably gonna start here with this section with for JavaScript developers. I hope that's not it. No, here we go. From start to finish. This is the one we want. I found it yesterday. We'll find it again. My speed is 110 VPM with 100% accurate. That's really good. Well done. So there's a huge difference. So now I'm starting to practice on the 5K ones because the words are much longer, right? And it's quite I was like trying to see how you don't even use these words day to day, but actually you do pretty much all of these probably. Okay, let's get these hands nice and warmed up, and then we'll have a look at TypeScript. I started using my pinky finger as well now to like hit the T words. If I can get my my 5K English speed up to like 100, I'll be really happy with that. Because I feel like this one, right, you can defo squeeze in a ton more words, right? Let's try. Oh no. Caps lock, not now. Not the best one, but of course you can tell that it is going to be faster. The words are much shorter. Okay, anyway. Back to the 5K. That's what we need to get good at. You should try JS instead of English 5K. There was a reason why I didn't want to do the JavaScript one, but I forgot what the reason was. Oh yeah, the reason was I don't want to do I have auto pairs. So I have it in my muscle memory. So like all of these things, that's so funny. Upload thing is here. Upload thing on DB, right? Now this is the problem. I have to complete that. Yeah. But yeah, we might. Oh, okay. My hands are warmed. Okay, let's find this. Let's get going with the TypeScript. Binding caps locks to control and using to delete words. Yeah, that does boost your typing for sure. Okay, we'll stop. We'll do a couple here and there. Pa, pa, pa. We'll hop in. We'll hop out. Okay, Typescript. Why do we use TypeScript? Let's see why. Where's the handbook? Was this the one? I found one yesterday. Just give me a second. Let me see where I can find this. Okay, well, I guess we'll just go from here, right? Are you using the mouse on the browser? Oh, I am. Yes, I am. Illegal. And I got Vimium installed as well, which is funny. But I'm gonna be using the mouse now because I'm still not super comfortable with Vimium. Am I dumb? I must be really dumb because I swear this is where I was and it was not this website. Or at least it was more than like what we have here. GSX handbook. Okay, here, right? And then everyday types. Okay, we got it. It's here. All right. Let's get ready. Hypocrite? Yeah, I'm a defo. Can you say something in Polish? Oh, I don't know any Polish though, but if you say something to me in Polish, I could try. Unless it's something that people are gonna go crazy about. Okay, so over 20 years after its introduction to the programming community, JavaScript is one of the most widespread cross-platform languages ever created. Yeah, you can run JavaScript everywhere these days. You got Expo, you got you can pop it in the toaster to heat your popcorn up, everywhere. While the size, scope, and complexity of programs written in JavaScript has grown exponentially, the ability of the JavaScript language to express the relationships between the different units of code has not. Combining with JavaScript's rather peculiar runtime semantics, this mismatch between language and program complexity has made JavaScript development a difficult task to manage at scale. It's just crazy to think back that you would... right, you'd have all this bloody JavaScript and you had no idea if your types were correct or not, or if you'd have undefined or something, right? All the type guards and everything that you would normally do, you could super easily miss it. If you're coming to TypeScript without a JavaScript background, with the intention of TypeScript being your first language, we recommend, no, we know JavaScript. We know everything about it. Can you say something in Romanian? Salut, ce faci? Narrate the handbook and release the audiobook? Yeah, maybe. We'll go through every single line. All right, so how's this handbook structured? All right, we'll be fine. We can go to the get started. Let's go with the basics. Let's get started with the basics. Okay, cool. So now we need our... Let's pop this window here. Poof, poof. Let's pop it there, actually. We'll make the space for it. That should be enough space. Yeah, let's bring it like that so it's like mobile view. Perfect. Okay, so let's go into CD. We'll go into Playground here. There we go. And then we'll make a McDur. I'll have 2 McDurs, please. No chicken nuggets. And we'll call this Reading TypeScript. Developed by Ed. CD. Hey, why did Siri activate? Thank you so much for the follow. Scarlet B, I think it's so hard that the pixels are small on the screen. So if I botched your name, I'm sorry. What OS do I use? I use Arch. What terminal am I using? I'm using Kitty. And font is Kanagawa. Okay. All the follows. Thank you so much. Mr. Sinister, I appreciate that. Okay, so let's get going with TypeScript. So the first step that we're gonna do is let's create a index. Sorry, we gotta touch it. Gotta touch an index TS. Has it been touched? Probably. Let's have a look. This is my new cover. You guys like it? Here we go. So we are in the index. We should also probably npm init. Why? Because npm install pum install Typescript. Pretty good. All right. We up and running. ESLint not found. Don't worry about it. Okay. Each and every value in JavaScript has a set of behaviors you can observe from different operations. This sounds abstract, but as a quick example, consider the operation we might run on a variable named message. All right, so let's just copy this over and then we'll see what it wants us to do. ESLint, we don't care. ESLint. Shoo. Okay, here we go. So we got message, right? So accessing the property to lowercase on message and then calling it message.toLowercase. What is it trying to say? That you cannot call it because it doesn't because the name doesn't exist? Is that what you're trying to say? See ya. Hey, see ya. Hi, nice to see you. Okay, so I assume that's it, right? Okay, cool. Anyway. Okay, so if lesson number 1, if the thing doesn't exist, you can call things on it. Cool. The first runnable line of code accesses a property called toLowercase. So this is a string method, right? And then calls it. The second one tries to call message directly. So like that, calling message. But assuming we don't know the value of message, and that's pretty common, we can reliably say the results we'll get from trying to run any of this code. All right, so we don't know what message is, right? That's kind of the whole point that it's trying to make. Is it a string? Because if it's a string, then we can do all of these string methods on it, right? Is it callable? Does it have properties called toLowercase on it? If it does, is it even callable? Right. To answer the questions are usually things we keep in our heads when we write JavaScript. And we have to hope we get all the details right. Yeah, because normally you wouldn't have anything to tell you, hey, you are working with a string, so these are the only methods that you can use. You want a to uppercase, whatever, I know that you can use it safely because I know the bloody thing is a bloody string. This is like reading ABC, but with the C, D, E, F, G added on top of it. As you can probably guess, if we try to run, okay, we know. Okay, so you get a type error, right? Message is not a function. Okay, it'd be great if we could avoid mistakes like this, and we can with TypeScript. When we run our code, the way that our JavaScript runtime chooses what to do is by figuring out the type of the value, what sorts of behaviors and capabilities it has. That's part of what the type error is alluding to. It's saying that the string hello world cannot be called as a function. Is that even worth trying? Nah, it's fine. For some values, such as primitives like strings and numbers, we can identify their types at runtime using the type of operator. But for other things like functions, there's no corresponding runtime mechanism to identify their types. For example, consider this function. So you have a function called fn that takes an x in as an argument, and it returns x.flip. We can observe by reading the code that this function will only work if given an object with a callable flip, right? We don't know if this X has this flip method on it. But again, JavaScript doesn't surface this information in any way that we can check while this code is running. The only way in pure JavaScript to tell what the function does with a particular value is to call it and see what happens. And you know what happens? Nothing good. Ever. Seen in this way, a type is a concept of describing which values can be passed to a function and which will crash. JavaScript only truly provides dynamic typing, running the code to see what happens. It just doesn't know any better, unfortunately. The alternative is to use static type system to make predictions about the code is expected to do before it runs. All right, so essentially what we do is, if you know the types, you're not gonna make stupid mistakes. Think back to what the type error we got earlier from trying to call a string as a function. Most people don't like to get any sorts of errors when running their code. Those are considered bugs, yes. And when we write new code, we try to avoid introducing new bugs. If we just add a bit of code, save our file, rerun the code, and immediately see the error, we might be able to isolate the problem quickly. But that's not always the case. We might not have tested the feature thoroughly enough, so we might never actually run into a potential error that we would be thrown. All right. Or if we try lucky enough to witness the error, we might end up doing a large refactor. Yep. Okay. Ideally, we could have a tool that helps us. Okay, so here's the type checker. Static type systems describe the shape and behavior of what the values will be when we run our programs. A type checker like Typescript uses the information and tells us things that might go off the rails. All right, so if we do a colons message here, colons message, right? Hello. And then if we try to call a message, that's going to throw an error, and it's going to say the expression is not callable because strings are primitive values and cannot be called. There we go. Let me just have a little Dr. Pepper, okay? What's this thing? You getting bloody bots everywhere. Time to ban the bot. Block. Okay, cool. I want to get back into TS and JS stacks. Yeah, they're super fun. Hey Ed, hope you're doing awesome. I'm doing really well. Thank you so much for joining us. I'm completely burned out. I can barely look at code anymore without feeling sick. Anyone else hit rock bottom like this? Oh, it's really tough. Yeah, I've been in that position a couple of times. Yeah, it is really hard to get out of it. I feel like I always just end up coming back to coding. I just love it so much. But a healthy break defo helps. You know, it's usually sometimes when you start overdoing yourself. When you go really hard, try to code 10, 12, 15 hours. And then when you take a break, you just feel donezo. Of course, a lot of times people can take breaks because, hey, it's work, right? It's their work. Do one push-up per error. We'll do that. What is the plugin that shows the pretty error lines? This one is called... hold on. Tmux. Let me make 2 panels here. Sorry, it's gonna look chaotic for a second here. It's called... Was it indent line? One of these, hold on. I think it is this one. indent line. Have a look at this one. If it's not this one, I'm not sure. I'll have to look again. Okay. Let's keep going. All right, so this makes sense, right? So it catches, it knows the type. If it knows the type, it cannot be invoked. Non-exception failure. So far, we've been discussing certain things like runtime errors, right? So if I try to run this, I'll actually just go back here, cd playground, and we call this reading TypeScript. Okay. Siri keeps activating when I say that for some reason. Stop it. Okay. So if I do node index ts, oh crap. There we go. We got a type error. Message is not a function, right? It doesn't work. Cool. Node, we should do bun instead. But yeah, anyway, it just looks nicer. Look, it does red. Node doesn't know how to do red. Node is really dumb. Okay. So non-exception failures. So far, we've been discussing certain things like runtime errors. Cases where the JavaScript runtime tells us what it thinks something is nonsensical. Those cases come up because the ECMAScript specification has explicit instructions on how the language should behave when it runs blah blah blah. For example, the specification says that trying to call something that isn't callable should throw an error. All right, so this is what the folks decided. They got in the room and they decided that if you try to call that, they're not having any of it. Maybe that sounds like an obvious behavior, but you can imagine that accessing a property that doesn't exist on an object should throw an error too. Instead, JavaScript gives us a different behavior, so it's usually undefined, right? That's what you get. So we can have a look at that. So, all right. So when we call something like this, const user. Let's make this name, say Daniel 20. Okay. User, the location. So this is not going to crash your app. It's just going to set it to undefined. So user, the location. Sorry, let's just console log out. Okay. And then you can go as deep as you want. Bun index. There we go, undefined, right? And then you can, it doesn't matter if you do blah 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 the blah blah blah. Oh, it does. Never mind. But if I do this, then that's still gonna work. No? Yeah, it does. Boom! Hack the system. What's good? All right. Whoops. Let's go back. Okay. Okay, so there we go. Accessing a value that is not on our object is going to throw undefined. Ultimately, a static type system has to make a call over what code should be flagged as an error in the system, even if it's valid JavaScript that won't immediately throw an error. In TypeScript, the following code produces an error, but location not being defined. Okay, so property location does not exist on type, All right. Do we see the error? It does. Okay, it does pop up. Cool. There you go. While sometimes that implies a trade-off in what you can express, the intent is to catch legitimate bugs in our program, and TypeScript catches a lot of legitimate bugs. Honestly, since I started using TypeScript, I feel like 99% of the bugs have just gone. And I also feel like a lot of like unit tests I used to write to are gone too. And that's good news. That's great news. All right. All right, so let's have a look at this. So for example, typos, const announcement equals hello world. Can you quickly spot the typo? Announcement, announce. The locale, local, is that it? Locale, local? It is. Who needs TypeScript, am I right? What kind of keyboard do I use? I use the MX. I use the MX keys by Logitech. They're awful. By the end of the stream, we'll buy another one. Okay. We'll do a quick pause. And pop open Typer. 3, 2, 1. Reset, reset. No. Slow. Okay. While sometimes it implies, okay, where were we? Here. Okay, so catches that, right? So let's try it. It says, okay, to locale or does not exist and blah, blah, blah. Cool. Okay. Uncalled functions. Flip coin. Return math.random. Did you mean math.random? Okay, cool. Or basic logic errors. So we have a value, math.random is smaller than half. Then we get either A or B. So if value is not equal to A, then we can do whatever we want. Else, if value equals to B, this comparison appears to be... Why is it unreachable here? There's no overlap. Okay. Types for tooling. TypeScript can catch bugs when we make mistakes in our code. That's great, but TypeScript also prevents us from making those mistakes in the first place. The type checker has information to check things like whether we're accessing the right properties on variables and other properties. Once it has the information, it can also start suggesting, so if it knows what it knows, then it can start suggesting the relevant methods. So it can leverage the editing code, and the core type checker can provide error messages and code completions as you type. Yeah, so you get all this nice juicy stuff, and then where's, oh crap, I didn't have the right screen on. No. All right. You did the best much. You did the best much. All right, so TSC. Here we go. This is the compiler. We've been talking about type checking, but we haven't used one yet. Let's get acquainted with our new friend, TSC, the TypeScript compiler. So you npm it, pnpm it, install it globally. And then, okay, so we tried this. We're just using bun, so we don't even need that. Sorry. Also, let me get rid of this. We don't need the, because I'll switch over to the chat. Sorry. So I'll just take this off for now because it's making the text look quite nasty. There, just to keep it a bit cleaner so it's easier for everyone to see. Okay, good time. Okay, so we don't need this because we can simply run bun. So we'll just ignore this step. Okay, TSC, whatever. Let's get, where's the fun stuff? Here. Still not fun stuff. Emitting errors. When no. Okay, here we go. We're kind of getting into it here. We should just probably get down here, honestly. Should we go through all of these rules as well? We'll go through them as well. Okay, let's just do it. Screw it. We'll learn all about the rules as well. You gotta know the rules. Explicit types. Up until now, we haven't told TypeScript what person or date are. Let's edit the code to tell TypeScript the person is a string and then date should be the date object. We also use the toDate string method on date. Okay, so in a function, right, you have two parameters, person and date, and then you add the colon there, and then you define, this is the type, right? So you can say type of string. And then here we have type of date, which is an interface. And there we go. All right, cool. What we did was add type annotations on person and date. That's what they're called, type annotations, sorry. To describe what types of values greet can be called with. You can read the signature as greet takes a person of type string and date of type date. With this, TypeScript can tell us about other cases where greet might have been called incorrectly. Okay, so let's look at this example here. Here, we'll copy this function over. Hey, not that one, this one. Here we go. Okay, there we go. So date has a person and a date, and then when we call it, so let's call greet. As you can see, we get that nice preview as well, since it knows the types. So it knows that person is going to be a string. So if I try to pass in a number, it's going to error out. So let's do that, something like that, 23 and 23. It's going to say that argument of type number is not assignable to string. So we have to do a string. Let's do develop by ed. There we go. So that's fine. And then that says it's a number, so it needs a date. So let's pop in the date, and I give you a date. This is the only thing that's annoying about noise, is the notification up here is just blocking your text. Real annoying. Okay. There we go. So new date, and there we go. Super cool. Oh, here we go. Look, I wrote it before it. I wrote it correctly. Okay, so if we leave it like this, it says TypeScript reported an error on the second argument. Perhaps surprisingly, calling date in JavaScript returns a string. Proof? Let's prove it. Check this out. Const test equals date. And look at that. Would have you guessed that date is a string? Console log test, console log type of test, boom. It's a string. Crazy. Are you using Camlink? Yes, I am using the Sony A7 S3. It's a fantastic camera. I love it. It's got good blur on it. Good quality. I'm only streaming in 4040p. Is the autofocus quick enough with it? Not quick enough. Okay. So, if you got a date, do you have a date? If you need a friend, if you don't have a date, we can go together. We'll find you the love of your life. But date is a string. If you invoke date like this, no bueno. So we can fix this up. Don't worry. We just called the new keyword. So, on the other hand, constructing a date with the new date actually gives you what you were expecting. So, add the new date. That's it. So, test2, new date, right? This calls the constructor and actually just returns you the whole date object. Pretty cool stuff. Okay. All right, we're doing all fine, right? We all know the basics of TypeScript. This is smooth ride. Keep in mind, we don't always have to write explicit type annotations. In many cases, TypeScript can just infer or figure out the types for us. So meaning, if you have a simple variable, right? You have a const title of my website or something, and this is called my website. Okay, we don't need to go here at, wow, this noise is really irritating with these pop-up notifications, I'm not gonna lie. You don't need to come here add string, right? Okay, I'm gonna remove this thing. It's annoying me. Where is it? Where are you? Here. Be gone. That's fine. I don't mind it down there. I want to learn front end. I'm also doing Golang for backend. That's really exciting. Maybe that's the next one we can do after we finish reading all of the TypeScript documentation. We can maybe do Golang, and then maybe we can build a fun project with it as well. That would be fun on stream. Okay, so basically, when you have a variable, in this case we have a constant here, but it can be a let as well. Hold on, let me change it to how they have it in their example. Okay, so you have a let, right? Since you specified this as a type of string, you don't need to add the type to it as well. TypeScript is smart enough to know. So if we save and we have a look at this, then we can say that it's a type of string. Now what happens if you go here and change it? So if I do title equals 2 now, because I can do that, like there's nothing like really stopping me, right? Console log title out here. All right. 2, see? So it does work. Like, again, this is just kind of, imagine TypeScript as being a superset on top of it. You just got the types on top of it, but when your code actually runs, it's only JavaScript. So everything, all of this is going to be like removed, stripped away. So as long as it's let, you can still do that. Is this the Kanagawa team? It is. It's a very nice team. And what are you going to make after learning TypeScript? Well, I'm working on my course platform, so that's like the big project I'm making, but we can make something fun on stream. So I'm building this out right now, which is going to be pretty cool. So I was just working on this now, which is like the kind of side panel for the course here, because we have a couple of different sections as well. So I was just building this out. I'm working on this whilst I'm off stream, but I thought we could maybe make a really cool, maybe a multiplayer something in TypeScript. That's kind of what I've been thinking of. A multiplayer something that we can kind of join, maybe like a kind of a game thing. I want to build it out with Cloudflare's durable objects. I think that'll be really interesting. React, TypeScript, and Cloudflare durable objects would be really cool. Okay. So yeah, off stream, I'm really working on the course platform, getting that up and running. It's going to be super, super exciting. And then I have a couple of things. I'll order a keyboard as well that we're going to, from the list that you guys send me, and then we're going to do an unboxing live on stream as well. That's going to be super fun. And then we'll see if it improves our typing speed or not. Speaking of, we need a run. Let's do a 1K. Let me just warm up. Hey, not bad for the first run, eh? Any idea how to handle video streaming on the platform? So the way I'm doing it on my platform is I'm using R2. This is just this is not me. It's just a temporary image I found, sorry. But the way I'm gonna do it is essentially through R2. So I just have a bucket, and I generate M3U8 files. So I take an MP4 and I break it down into little chunks. And this way, as you can see, look, I can get the streaming in chunks to come in. So it just starts really, really quick. And like if I go through this, like look how fast these videos load, and they load up to 4K as well. And then you can block this content if you want. So this is just a public bucket right now that I'm streaming, and the egress is free, which is super nice. But from here, if you want to close this off, I'm going to be using Cloudflare's firewall thing to essentially kind of block access. My coding journey started with you. Hey, how's it going? I'm glad that you're still here. Here I am. Okay, here we go. Okay, let's do 2 more. Damn, we were doing pretty well. Look, we were averaging 126, 124, 126, 120, and then slowly started going down. 116, 18, and it died out. Okay, let's continue. Here we go, emitting with errors. One thing you might have noticed from the last example was that our hello.js file changed again. Well, we haven't really bothered with this, but let's just keep going. So TypeScript doesn't get in your way. Of course, over time, you may want to be a bit more defensive against making mistakes and make TypeScript. So what's this no emit on error again? In that case, you can use the no emit on error. Try changing your hello.ts file. What is it? Do not emit compiler output files like JavaScript source code, source maps, or declarations if any errors were reported. Okay. That makes sense. So you want this on, pretty much, right? No emit error. Because then if you have a bug, is that what I was saying? Has my window app split like this? Yeah, it's just Hyperland. Super cool. So I just got the both chats up here, and then I can open up more like that, or like another browser tab if I want to, or anything else here like that. And then I do super key, and then I can switch between the tabs like that, which is really nice. Explicit types. Let's have a look at these guys. Up until now, we haven't told TypeScript. Wait, I read that. Erase types. Let's look at what happens when we compile the above function greet with TSC2. Okay, so let's try this because we haven't actually tried any of this, right? Well, let's recreate the example, right? Function greet. So it was like this. It had a person, that was a type of string, and it had a date, that was a type of date. And then we console log, whatever. I'm not going to bother console logging that, but let's just put it there. And then we do greet, and then test, and then new date, right? Okay, so go here, tsc index ts. I don't have the tsc command. Should probably just set up here, right? Jesus. Why doesn't not want to open the rest of my files? There we go. Silly bugger. Okay, so what? TypeScript is easy to learn, but we'll see. We'll see. It's nice and smooth so far. I mean, I know TypeScript, but I just thought it'd be really fun to go through everything in the docs. Because when you don't know everything, always keep in mind there's always something that lurks. Don't forget to use Control Backspace to fix an error and then repeatedly pressing back. That's true. I need to get that in my muscle memory. Okay, so what happened here? It's because I didn't install TSC globally. That's it, right? So we can do, let's just call it build, right? Like that. npm run build. Did that do it? Here we go. Here we go. There you go, it did it. Now the question is, how come it didn't add the use strict on mine? But it did here. Look, use strict. I didn't get a use strict. Delete. I want my strictness. Oh, here we go. Different users come to TypeScript looking for different things in the type checker. Some people are looking for a more loose opt-in experience. We don't want anything loose, okay? Which can help validate only some parts of their program. Still have decent tooling. This is the default experience. We want full strictness. We want, I'm not gonna say, where types are optional, inference takes the most lenient types, and there's no checking for potential null undefined. We want to check for everything. Much like how TSC emits in the face of errors, these defaults are put in place to stay out of your way. If you're migrating, we're not migrating anything over JavaScript. We're full TypeScript, baby. In contrast, a lot of users prefer to have TypeScript validate as much as it can straight away. Correct, that's the correct answer. And that's why the language provides strictness settings as well. The strictness settings turn static type checking from a switch, Nintendo's, either your code is checked or not. So you just want to check, right? Having any as your type or stuff like that just makes it useless, right? Might as well not use TypeScript. We need more of this kind of stuff in the world. Love this. Okay, yeah, well, I'll be here. We can do a whole series. We're reading the book of TypeScript. We can read the book of Golang next or C or whichever, and then we'll build some fun stuff. Which distro, right? This is Arch. Arch Linux, yeah. Okay, so here we go. TypeScript has several type checking strictness flags that can be turned on or off, and all of our examples will be written with all of them enabled, otherwise stated. All right, so the strict flag and the CLI or strict true in your TS. That's why. So we don't have a tsconfig, right? So that's why it didn't add the strict to it. Correct? Am I mistaken? So no implicit any and strict not. Okay, so let's turn these on. So let's go here. tsconfig.json. Let's look at this strict flag. Where am I? Wait. I have a little question. So what does the TSUp do then? Okay, so this takes in TS and TSX natively as well. And CSS support as well. Right. Just so I can know like the differences. Because the JavaScript ecosystem can be a bit mind-numbing, you know? Like, we have TS up, TS down, roll up, roll down. Okay. So we're not using this, we're just using TypeScript. Let's just go here a little bit. We did this. No, okay, they don't really say anything else. Okay, anyway. My only question was, hey Python guy, thank you for joining. Yeah, this is Hyperland. You can TSC init. See, that's what I needed. But I guess I wanted to like go through line by line, but let's just pop one in, right? TSC init dash dash. Oh, that wasn't it. What was it? TSC init. It's because I don't have it, that's why. Oh, they need to bloody install this globally. Let me just put it here. Just so we can see as well. Let me try this. I know, like, this is a stupid way to do it, but anyway. Okay. So there we go. So created that for us. So now the question is, now that well, I still want to just see if that's what happened with the strict thing. So I'll go here, make this a bit smaller. See, this is why people are scared of this. Look at this thing. Jesus. I was gonna comment everything out. Okay. npm run build. So now that should have this. It doesn't have the strict audit. Why not? Build again. Huh? What? Why? I love that you're reading the docs as in the old days and not using LLMs. There's not going to be any LLMs. We're going to lead every text line by line the way the person that wrote it intended it. How long did it take you to learn Vim? I'm still learning it. I still feel like I'm not too good at it, but I can like, I feel like the basic commands to like really get by without really thinking about it. Because that was one of the hard things, is to like not think about the actual commands. What editor are you using? This is NeoVim. This is good old NeoVim. So for example, This might not be a good example, but let me go here. So maybe I'm here, right? So it's like really nice and easy to navigate around. I'm in nice here. I can set a marker, M1, for example. I can go, for example, here. Let's go here, right? Go down, and then I can put a marker here, jump back to here, jump back to there. So it's really nice to work with. I like it a lot. My question is now, okay, is why am I not getting it the way he's getting it here? See, we set the strict to true, so that should do it. Is it not reading my tsconfig? Would that be it? So let's see what we have here. Target 2026. Okay, so that's the target module here is CommonJS. Why is this CommonJS? We'll need to switch that. What else is activated? ES module interop. Emit additional JavaScript to ease support for importing CommonJS modules. This allows synthetic default. Okay. Force consistent casing in file names. Yeah, that's fine. I'm happy with that. That's a good one to have. Type checking. Here we go. Strict. Enable all strict type checking options. And then implicit no. Okay. And then we'll try it. Well, let's see if this works, right? Because the no implicit any basically means it won't allow you to compile it, right? If you have something with any in it. I'll set a marker here. We'll come back. So let's see if that works. So if I do something like const, well, even I can do something like this test, and I can add an any to it, right? Let's make it a let. So see, that works, but it shouldn't work because I had no explicit any. Oh, it's not turned on. Hold on. Let me turn it on. What is going on with this? No implicit any. There it is. Okay, so if it's on, what? Do you have Copilot in NeoVim? I'm trying not to do any LLMs. Teach a bit, please. Or it's you wrote all the scripts? What you mean by that? Is there any reason for not using LLMs? I use LLMs. I use LLMs when I write code, a lot of code especially, and just to speed up stuff for sure. Just I feel like when you're learning stuff, if you're using a lot of I still think it's like go through the docs and you actually type the code out and see like, okay, that does that. Oh, cool. That moved like that. Why is that red squiggly? Oh, because of that. I think it just clicks more with how my brain works. And I honestly feel like probably for a lot of people, it's more beneficial to just like do the trial and error and just go through the stuff. And then the power of that is like when you come back or you like run into a problem, you're like, oh, actually I ran into that problem when I was doing this bit in Astro or whatever, right? So I think it's a good idea to do it once. Just speed run through it if you can. Okay. So like this is a perfect opportunity now to ask GPT. Okay, so we did a tsconfig here. I added the strict, and the no implicit any, but it's not doing it. Okay, so let's ask the GPT why. Here we go. Just pull this here. I still don't know how to pop this in. Okay, anyway. It's stick. It won't stick. I created a tsconfig.json and installed Typescript. The problem is if I turn on no implicit any or strict true when I run tsc index ts, the use strict is not on there. Also, the no implicit any is not working. So let's see. I might have missed something. How do I take this tab? Hey, Darth Vader, thank you for joining. Thank you for joining us and taking a break from Fortnite. Here we go. By default, TypeScript does not inject the use strict. It compiled. Okay, here we go. So by default, TypeScript does not inject use strict in compiled files if you're using modules like import export, because ES modules are strict mode by default. If you want to force use strict to appear in non-module JavaScript output, you can use this. Oh, is it because always strict? Wait, let me read that again. So is it because I'm using, so if you're using ES modules, then it would, but since you're not using ES modules, it wouldn't? Well, we can test that, right? So if I go here, make a new file, let's call this yell.ts. Something's screwed up here. Why would you not let me open that? Let's try. So we got yell. Okay, I'm gonna delete everything here. I'm sorry. Because I think that's the thing that actually might be throwing me some errors. So yell, right? We got yell. And then you do export. So we'll export this module, export default function yell. It takes in one yell. It takes in a shout. That's the type of string. And it returns the shout dot to uppercase, something like that, right? Something ridiculous. Okay, cool. So we got the yell. We can go to the indexes. I have no idea why this is like erroring out so crazy right now. We go here, we import Mr. Yell, and then let's also do a console log yell. Oops, let's save it. Okay. Oops, it takes in a string. This is gonna be uppercase. Here we go. We'll run the build. It did it. All right. See, I didn't even know that. Okay, so when you're using modules, the strict will be added. Good to know. We learned something new. What do I prefer, ChatGPT or GitHub Copilot? I don't use Copilot at all, and the rest I usually use until they tell me that I ran out of credits. So I usually start with Claude, and then it starts yelling at me, you don't have any credits. Then I go to GPT, and then Google Studio, the Gemini, I think, has been pretty good too. If you go over to this one specifically, because you got like the million context, so it's pretty good. So I go here, you can dump in a million, and then it does a decent job. But again, sometimes I do, sometimes I don't. Okay, so that works. That's good to know. Cool. So if we use modules, this use strict will be added automatically. We can close GPT. Thank you for your efforts. Okay. Different users come to TypeScript looking for different things in the type checker. Some people are looking for more loose opt-in experience. Okay, so we read that. In contrast, a lot of users prefer to have TypeScript validate as much as it can straight away, and that's why the language provides strictness settings as well. These strictness settings turn type checking from a... We learned... read all of that. Oh, okay, so no implicit any. Recall that in some places TypeScript doesn't try to infer types for us and instead falls back to the most lenient type any. So we still haven't tested this. So this makes sense why this works. And look, at output both of our files here for us. So it doesn't... So TSUp, right? That's what TSUp is gonna do for you. It's gonna nicely bundle all of these in together for you. And actually we can try that as well. So if I just delete, again, for those who have not seen, all right, all we have is an index TS here that essentially imports, oh crap, I deleted my YEL. No, I don't even have a repository set here. Okay, that's fine. That's fine. Close. I'm in the matrix. I'm in the matrix. Okay, well, it wasn't anything interesting, but it basically generated both files for us, right? Okay, so recall, blah, blah, blah. So this still hasn't worked. So let's try let test any equals, well, even like that, right? So why I have no implicit any turned on? What even is this error? Why? Why are you trying such a nasty error? Okay. Let's go to the tsconfig reference here. Here we go. So let's just do it from scratch, right? So we understand every little setting. We'll do compiler options first. Okay, let's open this up. So this is kind of the meat of it. That's where it's gonna be, right? So we'll say strict to true. And then we'll do the no implicit any as well. Set that to true. Okay, so that should be enough for it to kick it off, no? How come this is not getting highlighted or caught here? And then we'll do the strict null checking as well. Yeah, super strange. Let's see. Currently building my second Next.js project for my portfolio. I'm still a noob. Next.js is a good way to get going. To be fair, it's quite easy. Do you have a streaming schedule, or you hop on when you have time? For now, I'll just hop on when I have time because we're having a baby in like the next literally 2 weeks, so it's gonna be a bit crazy. But after that, I'm gonna be coming on probably more usually. I'll make up like a streaming schedule. I'll probably make a video about it or hop on here. But I wanna like take streaming a bit more seriously. I think I should have done this ages ago, and I kind of missed out on a boat, but it's never too late. And yeah, it'll be at least like 2 or 3 streams every week, where we're gonna just hop on, pick something that we're gonna do, and just have fun with it and chill out. I think that's gonna be great. And I do stream on Twitch as well now, so I'll do the multi-streaming. I set up one for Kick as well, but I haven't even like seen anything like any good like categories there where I could even like start streaming on. So I was like, I'll just leave it for now. We'll do Twitch and YouTube's, but who knows? Maybe we'll do a crazy gambling stream or something. You never know. Okay, let's ask Jippity. This is a Jippity question. How come I created a tsconfig.json and also a simple index.ts, which has in my tsconfig.json, I set up no implicit any, for example, to test if it catches it, but it doesn't work. So let's see why. So let me just tell it. So my index ts is like that. Okay, and then we can go over to our tsconfig. I wonder why this happens. There you go. Here you go. It only okay. So that should oh. Well, so if, that makes sense. So if I do any on my, so that should catch it, right? Because I explicitly told it, hey, it's any, but it's still not complaining. But it's not true. See, that's the thing, though. It's not true. That's sketch. What's this error as well here? Because it's pissing me off. Here we go. Neo3 error. Oh, it's the ESLint error. Okay. Silly. It's not doing it. And I don't understand why. Processing buffer, right? No such file or directory. What are you talking about? What do you mean no file, no directory? It's right here. And I wonder if because I did this. Sorry, let me just have a quick look at this. I thought that might cause some weird issues, but looks like it doesn't. Let test. There. Type. It says type any. TSC in it. Let's get rid of this. Build. TSC. Index. No emit. Expected double quoted property name in JSON, blah, blah, blah. No emit index, failed to parse JSON. Package.json must be actual JSON. What? It is. What are you complaining about? On what line? Line 8 in my JSON. Okay, well, let's put the no emit back. Here, there, line 8. Oh, my commas? I have my comma. I'm not seeing it. Okay, let me remove it. What did I do? Did I do something to my package.json? There, I went back. What? That's weird. It's not gonna be the ESLint thing. Line 7, comma, could be the oh, there was a comma there. Bloody hell. Oh, there you go. Thanks. I appreciate that. Okay. Why is the thing not working? Because that should catch it, right? No explicit type. It should give you. Are you sure tsconfig is in the same folder? I'm pretty sure. If I write still not working, it's highly unlikely you're gonna help me, right? Have you considered just trying to help me? Strict, no implicit any. Oh, we forgot the files. That's why. See? I totally forgot you have to explicitly tell it what file. And then in frameworks, so let's have a look here. Now, how would you have it, for example, in something like tanstack start? cd playground / tstack worker. Let's have a look here. tsconfig. So you do something like this. Compile it. So include. Oh, I didn't have my files. I have another project that uses include. What's the difference between files and include? Pop that in there for them. Hello from Indonesia, India. Hello. How many of you use AI for coding? Yeah, actually curious. Probably, if I had to guess, if I had to do a poll, I'm not gonna do a poll, but if I had to do a poll, I'd guess like 75% probably of people. Here we go. We're learning, chat. We're learning. So you got maybe even in Next.js, right? Next.js and tanstack start and remix. You're gonna have something like this in your tsconfig. It's gonna say include. So the difference between include and files. Here we go. Files. So explicit list of files to compile. So you can just say explicitly, I want my index.ts. Okay, so that makes sense. If you use files, only those files are considered part of the compilation. Okay, so if you know that your project has a fixed number of things that you want to compile down, files. Highly recommend. Include, on the other hand, is a glob pattern that tells the compiler which files to include. Works well with projects with many files. So you can do /src / blah, blah, blah. Okay, so that makes perfect sense. So let's see. So we'll do index ts because we only have one file and we are happy with that. So now, hopefully, this will tell me that it's not working, and it still doesn't. Index ts. If you have neither files nor include, TypeScript uses the default behavior where it includes all the TS files in the folder and subfolder except for the node modules. Okay, so that makes sense. So for the no implicit any to trigger your index TS, it must be inside the included paths, like the root or whatever. But then this should work, no? So, well, let's see if this works like this, but it doesn't work like that. Then we'll get to, so if I do it like that, will that work? I need to be able to narrow the bloody problem down. Okay, so I must have some sort of a different kind of problem here, eh? Because that's not catching it either. But this should have caught it anyway, files index ts. No? I mean, we're pretty much on par. I guess I could have put like this into a source file, but it doesn't matter too much. Okay, let me catch up with chat, sorry. Hello from Saudi. Is your course on JavaScript and animation still valid? Yeah, I mean, they're very project focused. So if you want to learn like a cool project to make and you're quite used to JavaScript, yeah, highly recommend you to check it out. It's still gonna be a while till I remake those courses on the new platform. But yeah. If not, then just wait, and then a couple of months I'll have some new courses out, or anywhere else. You don't need to get from me. Let's see. At one point in time, AI can do everything that person can do at one point in time. I mean, yeah, probably. That's probably gonna be the case. It's always like that. AI cannot do this until it can, or it's gonna do a pretty good job, and then that's gonna be like the baseline, and it's only gonna be as worse as that, and it's only gonna get better. And that's why Anthropic has never touched image generation and video gen. How to do Svelte with GSAP? I haven't played around too much with GSAP or Svelte anymore, but yeah, we could have a look at that as well in the future for sure. Okay, well, the compiler shouldn't ignore it now, should it? That's my only question. Why is the no implicit any catching it here? It's not gonna be because of the ESLint either. Let me try something else. Does it do it here as well? Let me go to this project and try it here. Okay, let's go here. Const test. There we go. Why is it catching it here? Implicit has any type, so it works here. Let's paste it in here. Let's see. So it's not that. See how it's not working here either? Okay. Well, at least we know it's not the tsconfig. What the hell is it? Try compiling ts in your command prompt. It's not that it's not that I want to compile it in the command prompt though. It still should highlight it. Do I need to compile it first? Really? Why is it not gonna detect any? No, it still doesn't pop up with it. Weird. I just can't tell why. How come it works here but it doesn't work there? Doesn't make any sense. TS. Where is this referenced anywhere else? Let's see. Not really. What is this? Vi tsconfig paths. Okay. tsconfig paths. Okay, so yeah. That's why. Maybe I should have just set up a V project, hey? I think this might be it because I'm passing the path there. Yeah, I think I just need to install it globally. I think you're 100% right. That's why. Yeah, it runs, yeah. Oh, why didn't we just do this from the beginning? I should have probably just done this from the beginning. Okay. Let's do it. Let's install it globally. So I did it here as well. Can close this up. That's 100% it. What's the global command for installing stuff globally with pmpm? Is it pmpx or did that get changed? Jippity. That'll be. npm has what's the mpx equivalent to pmpm? Okay. Let's delete this. pmpm dlx, that's it. Runs the package temporarily, downloads it if needed, and executes it without. Do I need that lx as well? Oh no. So pmpm, so can I do pmpm dlx typescript? I need to do globally though. What was it at TypeScript? Oops. Let's see. I'll find that. So if I do pmpm dlx g, is that gonna work? I don't need a G flag, right? There. Which one is it? TSC, right? What you mean that's not the TSC command I'm looking for? Which one am I looking for? Oh, whatever. npm installed. I'll just do it like that. Bloody hell. It's gonna take ages. Okay, so we installed it globally. So there's no way it wouldn't detect now, right? What? What you mean? TSC index TS. Yeah, so we got it's working. I got working. Look at that, it's generating the stuff. It's not ESLint. Because it's working here. Look. I go const test, right? Look, boom. It works here. pmpmdlx. Okay, yeah, that was it. Should be pmpm install g. It is installed now. pmpm adds g. Okay, let's try this. But I did add it anyway. Okay. ESLint. I do have ESLint, I just don't have the file. Try that as well. Okay. This is what I'm saying, we're learning. Okay, so we got TSC. Look, everyone in chat, everyone. TSC is here. Okay, we got TSC. The problem is it's not catching the no implicit any or anything. And then here we have the tsconfig here. We have the compiler options, strict, no implicit any, blah, blah, blah. And I cannot tell why it wouldn't catch it. If I set up quickly a Vite, it's gonna work if I do a project in Vite. cd. But I don't want to get a new one up and running. I want to figure this out now. I want to figure it out. You sure it's not an ESLint issue? I don't think so, because for example, in this folder here, right, where I have this project, I don't have an ESLint file either. Look, no ESLint files. And then I got my tsconfig, right? Which has got that. It's got the include to all the ts files and tsx files. So, and then it works here, so I cannot tell why. Yeah, look. Is it because I haven't specified what types of files I'm looking for? Wait, let me look at this tsconfig again. I'm facing ahead on this bloody tsconfig file. Maybe I think I need to define the base URL and the paths here. Maybe that's why. Maybe. Okay, I'll get the base. No, this is to set like your own path, right? If you wanted like an @ sign or a wiggly sign, that's why you use this. Which we could, I guess we could still do. Let's set that as well. There. Where's chat? I thought you guys were experts. I'm just joking. I'm comparing. Let's see. Okay, hold on. Can you do const test in a new project instead of? Yeah. Okay, I'll do that. You sure it's not an ES? Looks like it's coming from ESLint. How is ESLint running? It's not running at all. Can you disable it? Yeah, let's disable ESLint. The other tsconfig needs the include to tell it where to lint for. Hold on, I'm just trying to have a think. Because the bloody ESLint is for, like, TypeScript is still gonna do the type checking here in my nvim. Okay, let's go see what's with the nvim. Okay. Okay. So here's lazy. I am using, here we go, nvim lint. Nvim lint. cd config nvim lint. Here it is. Okay. So I set up here TypeScript and TypeScript React. So that's good, right? That's all I should need here. TypeScript and TypeScript React. And then in my Mason, ESLint. Okay, well, it's there. What you want from me? So that's fine. And then we should just give me a basic ESLint file. Give me a basic ESLint file with nice spaces, space rules, and whatever. You know what to do. Here we go. Okay. If your tsconfig JSON is at my project /tsconfig and your ts file is in /source/index.ts, but you open VS Code at the source, then TypeScript tries to resolve paths relative to. I see what you mean. Your index.ts has no errors, but it should be able to recognize this as a warning at least, because this is a type any. Okay. Well, let's add the ESLint JSON as well. ESLint rc.js. Unable to find ESLint library. What kind of format did this give at me? Get to Claude. Go to Claude. Try using a function with an any argument. Okay, let me try that. Okay, let's delete this. So function with like an any argument, const greet equals arrow function with user that has any in it, right? There. Oh. It works. It works. Okay, so now we can go backwards, right? We can like backwards engineer this. We'll figure the ESLint out as well. But let's go here now. We'll add these back later, just so we can kind of test everything out. We won't need this, right, to make it work. It's just the files. So that's just still error. Now the question is, if I remove this, comment that out, it shouldn't know now, right? With that commented out, it shouldn't know. Well, that doesn't make any sense. User implicitly has any type. Let's comment that out as well. Now I'm even more confused because of that. Look, I can probably even get rid of this file then. There. Look. Oh no, never mind. Okay, fine. Look, it's not showing me the error. Okay, we're making a good step now. The other TS config needs the include to. Oh boy. This TS config, hey, whoever made that. Okay, so here we are. Look. I think we're onto something. Let's go back down. Here we were at the strictness. Okay, so parameter user implicitly has a type any, but better type may be inferred from usage. Okay. So this is probably just like the global TypeScript recognizing this. Is that correct? And then when we go here, do we even need the files? Let's see if we just turn this on like that, and we leave the strict and implicit any on. Now it catches the error. Okay, lovely. Okay, so that makes sense. Now the question is, how come here it catches it like this as well? Because that question still hasn't been answered. So envim so it looks like I don't even need to specify the file here, eh? It's just, it is looking at everything currently. I'm just saying, like, generally speaking, it's just gonna look at everything, right? With TypeScript installed globally. And then it recognizes the TS config as well in the root, and then it works. Okay. So that makes sense. So again, the question is, how come here it also recognizes. Okay, let me ask that question instead. Because again, here I can do something like this. Cons declarations must be initialized. Banana. Okay. And then one more. Let boo. Declared by value never used. Okay. Let woo. It doesn't tell me it's declared but never used, but that's because this is a TSX file. So that might be it. If I go here. Oops, let. This is a TS file though. Test is declared but it's never read. Okay. Well, then what's the difference? TS config. Okay. We'll have a look through this. You were typing const test in those old projects, but in the new one you type let test. Here we go. We tried it now. I wanted to have it like here, like pulled up side by side. Okay, so we know what the strict true is. We know what no implicit type any is. No. Wait, that's strange. Look, here we don't even have it. No implicit type any, actually. So that makes me question if we remove it, then what? Not sure. Yeah. Yeah, I don't have it set up on this one. Const banana equals some value. Strict to turn this back on as well. Okay, anyway, we'll see. Let's see if the struct null checks work. So by default, values like null and undefined are assignable to any other type. This can make writing some code easier, but forgetting to handle null, blah, blah, blah. Okay, so let's see if we do a strict null check here. So the flag is, here we go. When strict null check is false, null and undefined are effectively ignored by the language. This can lead to unexpected errors. When strict null checks is true, null and undefined have their own distinct types, and you'll get type error for it. For example, here is a little code. So if you do user find, has no guarantee that will actually find a user. Okay, so let's give that a go. Okay, so let's say you have users, right? It's gonna be an array. We'll do some objects here, name, David, and then we'll do, I'm not gonna do an age. Let's just add a comma, name, John. There we go. Okay, and then we do const active user or something like that. Users find. We'll find the actual user here, and we'll tell user dot hey. Where's my autocomplete? Okay, so I'll just triple equal it to nothing here. Oh, here we go. What's it saying? Property find does not exist on type, blah, blah, blah. Do you need to change your target library? Try changing the lib compiler options to ES25 or later. Okay, so let's do that as well. Let's go here. Lib. How do I do this? Let's see. Let's yank that. There we go. We'll target ES 2022. Okay, can you let me do the thing now? Okay, there we go. U.name triple equals nothing. Okay, so let's try that. So again, by default, it says string or undefined. Okay, so setting strict null checks to true will raise an error that you have not made a guarantee that the logged in user exists before trying to use it. Okay, so you do that. That's like, this shouldn't be okay, right? You shouldn't be able to do active user dot name like that. I think did it catch it? It's possibly undefined. Okay, it does catch it. Nice. But here's the thing with it. This is what is so confusing. I don't have it set on. So what is going on? Is it on by default? Is that what's going on? And I'm just really confused. Strict null checks false. I'll explicitly put it to false. Oh, okay. Okay. This makes so much sense. So it must be then that the strict null checks and the no implicit type any are on by default or something like that, right? Hi, the Dreamer. How's it going? We're doing great. We are reading the entire TypeScript documentation until we understand everything in it. So it looks like the no implicit type any and the strict null checks are on by default. Is strict null checks and no implicit by any on by default? Because look, go here. See? It says it's nothing wrong with it. And then I go here. And I change strict null checks. I just get rid of it, which makes it on by default. And there you go. Look at that. It's possibly undefined. So now you need to actually handle this case. You need to be like, hey, if the active user name actually exists, then I want to do something. Or you can do, if it doesn't exist, if active user you'd be like, if there's no active user, then you return whatever. Okay, console log no active here. Otherwise, active user here, and now you got it. Boom. You can use it safely. Well, you can use active user safely here. .name here, it might still be undefined here, so you need to check for that as well. But at least see if I leave that, see how that's still undefined. Or you could and then check if the name is there or not, right? And then you don't need that either, because then you made sure. What am I doing wrong? I'm doing something wrong. So if no active user, it'll be here. Yeah, you do it here. Anyway, it doesn't matter. Okay. Oh. Let's also check this out. Just to answer the other question as well. Yell equals, we'll do a function. We got a message, right? Console log message. So that's type any, right? So it's gonna chuck an error for me. If I go here, what if I set this explicitly to false? No implicit any false. Okay, yeah, okay, it does work. It does work. There we go. No implicit any has any type of better, blah, blah, blah. Okay, so we learned a lot. We learned that you don't need any of these because it'll do it by default, so just leave it on. I'm still a bit confused about the strict. When does it actually, is this on by default as well? Here we go. Those are, yeah, okay. I am thinking of this. Strict null check's not on by default, but it is included when you have strict enabled to true. Okay, so that makes sense. So when you have strict set to true. Cool. Okay, so if we don't have this on, let's get strict out of the way, and then we know all the little settings in the thing. And that makes us happy, right? So look at it now. See? Not on. Okay? You add the strict. We gotta fix this ESLint error as well. Strict. We set that to true. And boom. There you go. All right, works. We figured it out. What's up? We are trying to figure out every single TS config command currently. That's the goal. Yeah, strict to true did it. Your code doesn't end inside the if block. In a function, you can return, otherwise you'll need to throw and get the type safety. Yeah, that's correct. I was just writing too much just in like TypeScript React. So I'm just used to try to return something from there. Okay, great. So we figured that one out. We figured this one out. We can move on. This is clear. Hopefully it's clear for everyone else in chat too. Okay, what's all this about then? So they recommend you to have strict on. What else did they recommend here? Oh, look, I must have missed a couple here. I did miss a couple. Let me just make sure I didn't leave anything out. See, no implicit override, no implicit return. What's all of this? Holy crap, the amount of... Okay. Okay. Here we go. Allow unreachable code. I don't want this. I know exactly what this is. This is when you do like a check, like we just did now, right? So if I do something like const... Sorry, let me try to think of an example. Well, here we go, right? So function, right? That takes in the number. So if it's bigger than 5, return true, else return false. So here, if I put something like 10, right? Then that's never reachable there. So it's always gonna, it's just gonna detect that, hey, that code is never gonna get executed. So you want this on. Oh, you want this off, sorry. Yeah, so we'll keep it off. So can I, let me try and make an example here. So n number, right? If n is bigger than 5, return true, else return false, return true. Unreachable code detected. Okay, so it gives you a warning. Okay, cool. Well, why did we even bother? You could have done something like if true, right? Return woo, and then anything else here is unreachable. That's unreachable. Okay, yeah, that's fine. Okay, so allow unreachable code. If we turn this to false, you will not get that little warning anymore. Let's try it just in case. Pop it in here. Allow unreachable code. Let's put this to false. Okay. And it should disappear. What? How come it's showing like this though? This is kind of how I wanted anyway, for it to be like an error like this. Is this on by default as well? Oh, I put it to false. Yeah, I put it to false. What in the world? That's what's confusing me about this. So if I turn it to true, oh look, it's not doing it. What sense does, what you mean if it's, oh yeah, because it's allow unreachable code. I'm so stupid. I need to curl up in a ball because we allow it. We said it's true. So it has the permission to be stupid. Oh my God. Okay. So make sure this is false then. Just get rid of it. Okay, next up, we have the lib option. We haven't really covered this as well. So that's Claude. Explain what the lib option does in tsconfig. Here we go. The lib option tells TypeScript which built-in type definitions to include in your project. So basically, if you don't have stuff like DOM in here, TypeScript wouldn't know to do stuff like, let's say you did like a document.query selector, right? And you have an element. You wouldn't be able to do dot add event listener. It wouldn't recognize this, right? So that's why you add the DOM in here. So DOM includes type definitions for these, right? Document, window, console, HTML, event, mouse. Okay, DOM iterable on the other hand adds iterable support. So for loops, node list, HTML. Okay, so that makes loads of sense. And then finally, ES 2020 includes all the features up to that. Okay, so has own, has the private fields and top level await, all that good jazz that we want. Okay, cool. Yeah, that's clear for everyone. Good. Okay, let's keep going. Allow unused labels. What is this? Undefined as the default, provide suggestions as warnings to the editor. So here we have verified. Where is this coming from? Unused labels are ignored. Raise compiler errors about unused labels are very rare in JavaScript and typically indicate an attempt to write an object literal. Oh, right. Okay, so we're never going to encounter that pretty much. Always strict. Here we go. Ensures that your files are parsed into ECMAScript strict modules and emit the use strict for each source file. So this will do it even if you're doing CommonJS and modules, right? Because otherwise it will only do it for the modules, right? Is that correct? Here we go. Exact optional property types. Okay, we'll probably switch out of this now. And then we'll come back to this, because look how long this is, by the way. And this is just the tsconfig, by the way. How did we end up here? How did we end up here? Oh, no, this is just so you can have your types. Look at this. Look at this. Holy smokus. This ain't no jokus. Okay. Back to the handbook. So I think we finished. We actually finished the basics, right? Let's have a look again. So we've done this, we've done this. We looked at TSC. We looked at some of the rules. What else is here? We looked at the strictness. Yep. Look at that. Little check mark. First one we finished. Hello, how's it going? All right, everyday types. We'll do one more. But first, a little monkey type. Oh no. Slow down too much there. Yeah, damn. We can do better. We can do better. Again. Not bad. Damn it, a little mistake there. And then let's do a big word as well. We'll go up to 5K. I feel like if we can get this up to 100 VPM, then the classic English one we can definitely do 140 at least. But the words here are still quite long, so it's not gonna be as fast. Well, let's see. Oh, see how much slower that is? So how was it? So type, and then shift backspace. No, control backspace. Ooh, that's it. So just in case, control backspace. Let's add that to the brain memory. Okay, I just need to get used to it. Let me just do it like that. Okay, cool. Ah, damn it! I ended up pressing too many keys. You gotta start off well, right? You cannot have a bad one at the beginning. just need to get it out of my head. Whew. Big words, big words. Okay. Practice done. Okay, let's continue. All right, so in this chapter, we'll cover some of the most common types of values you'll find in JavaScript. Okay, so we know about the primitives, right? In JavaScript, you have the strings, the numbers, and the booleans. Well, you have a couple more. I'm sure they'll get into it here. Okay. Here's all the primitives, by the way. You got big int symbol, null, undefined, and these. How many are there? 1, 2, 3, 4, 5, 6, 7. Yes. There we go. So string represents a value like hello world. We know that. Number, there you go. And in JavaScript, you don't have like special runtime values. So remember that, right? So there's no equivalent to int or float. Everything is just a number. Boolean, right? True or false. We know that. So the type name, string, number, and boolean start with a capital letter and are legal, all right? Otherwise, it's illegal. But refers to some built-in special types that will very rarely appear in your code. Always use string, number, or boolean for types like that. Okay, yeah. So you can do that, but so what's it saying is you can do, so let's say const to uppercase, right? So we can have an arrow function like this. Check this out. Also, ignore. What about the unreachable thing? The unreachable code. Test is declared. See, that's annoying otherwise, like that shows it like that. And it doesn't actually. Let me see how I had it here. Did I have it on? No, I didn't. Unreachable. But then how come here it's behaving differently? Check this out. Index. So if I go here and if I do if true return, then the rest of that code is unreachable, right? Okay, no, it's behaving how I thought it was gonna behave. So what, do I need to add this specifically on it to make it look super nice? Because I basically want this to be like unhighlighted. Okay, what was it called again? tsconfig unreachable code. Oh, turns out chat, turns out we just had to read. It says unreachable code. So by default, if it's undefined, it provides a suggestion as a warning to your editor. All right, keep that in mind. If you explicitly set to true, then it's ignored. Otherwise, it's just a suggestion. But if we set it to false specifically, then it actually raises a compile error about code that's actually unreachable. So this is actually really good. That was a very good explanation. Thank you so much. The documentation. Shout out to the docs. We learn something new. I'm popping this in old school. So let's add this. I do like this added. And we'll just set it to false. There we go. Now when we hit save and we head over here, we should see it. That, look at that. It's a big X. And then all the code here is going to be unhighlighted. So const, let's do a function, add some. You got a val1, val2. Anyway. But this code should be unreachable as well. Okay, I'll add the values. That's fine. Number here. Here. Number. Hey, how come this is... Oh, because it... My apologies. This gets hoisted, right? Before the code actually runs. This gets saved in memory as well. So that code is gonna work. But let's say for test dot what am I trying to do? I is smaller or equal than 10, I plus plus console log I. Okay, yeah, D highlights everything below that. Okay, good. Nice. Nice, we learned. Cool. Neovim with telescope is lovely stuff. It is. I absolutely love it. Really, really good. Okay, let's see what's next. So, head back over here. And so what it's also saying is that you want to avoid, even though you could add string like this. So if I do, we have a name, for example. This is Jon Snow, right? I could go here and say this is a type of string like that. What's the error now? Can I redeclare? I'll try and redeclare. There you go. Okay. So you can do that. I think that's what I was saying. You can do lowercase string, but you can also do uppercase string like that. But you'd want to avoid the uppercase string because keep all lowercase for types, because you have a big string anyway, and it can get really confusing. So for example, see how I have full name here? Or let's do this, const price equals 20, right? But I can do price. Oh no, it's toString. But I think I can also do const here, right? I can do a new string with the price, and I get type of string. And this is a constructor, right? Okay, what's going on here? Expected a comma. Expected a comma here. Unreachable code. I can't see from the bloody error. Oh, there we go. We forgot the comma there. There. Happy? Yes, save the changes, obviously. Okay, there we go, 20. And the type of this is gonna be a string. Type of. It's an object, sorry. There we go. Okay, so that's what you want to avoid with the uppercase, because then you have two things. You don't know if it's a type that's the string, or you're calling new string, as in calling the constructor to actually make it for you. So keep it lowercase. To specify the type of an array like 1, 2, 3, you can use the syntax number array. So again, if you have something like, let's do it with numbers instead, or strings. Let's do it with strings. User list, for example, right? So if you have this as Ed, Dave, John, right? So the type for this, you can say it's a number type like that. Now again, you don't need to say it because it's gonna automatically infer it for you. If you hover over it, you should see, there you go, string array. Okay, cool. You may also see this written as array number like that, which means the same thing. We'll also learn, so this is generics here, which is essentially like passing in a type as a parameter. But we'll get to that in a bit. Note that number is a different thing. So that's how you do with the tuples. Typescript also has a special any type that you can use whenever you don't want a particular value to cause any type check errors. So you can do that, add it a type of any, or you can do also ts ignore. When a value is a type of any, you can access any properties of it, which will in turn be type any. All right. There we go. So let object is type any, and then here you can do whatever, and it's not going to complain. So that's what makes it dangerous, right? You're just back to normal JavaScript. Here we go, no implicit any. We talked about this. When you don't specify a type, TypeScript can infer it. So the compiler will default to any. Usually want to avoid this though, because any isn't type checked. Use the compiler flag. Here we go. But we know, because we learned and we're smart, that we only need to add the strict to it, and that is going to do it and turn it on for you by default. Okay, type annotation on variables. So when you declare a variable using const, var, or let, you can optionally add a type annotation. But we don't need it because, again, as you can see here, it infers it, so it knows it's a string. Here we go for functions. Are the primary means of passing data around JavaScript? Yes. So here we go. We saw this as well, parameter type annotations. So we do the same, add the colon, add the string, bingo bongo, we are great. When a parameter has a type annotation, arguments to that type function are checked. So there we go. Yeah, it's checked. We've seen this as well. The return type annotations, I haven't mentioned this and we haven't tried it. So let's say you want to add two numbers together, right? So we create a function add sum or something like that, right? So it takes in two parameters. So let's say you have num1, which is going to be a type of number. And then you have num2, which is going to be a type of number, right? So we can just simply return num1 plus num2, right? So that you add the two things together. But you might have a case where, what if I accidentally do something stupid and I return a string instead? Right, so we're not checking here like what actually we're returning, if we care about it or not. So we just let it happen. So what you do is after the parentheses here, you say, hey, this is also needs to return a number. So now it catches it. This type string is not assignable to type number. Great. So now it works. We can do num1 plus num2. Cool. Okay, so that's the return type annotations. Much like variable type annotations, you usually don't need a return type annotation because TypeScript will infer it for you. Okay, functions which return promises. So here we go. If you want to annotate the return type of a function which returns a promise, you should use the promise type. All right, so you do a promise like that, and then you pass in the number. So let's give that a shot, eh? We'll keep everything. So it also said that it's gonna infer it automatically for me, so we don't need that. So let's see if that's true. How would I trick it though? That's the question. Add some, because this is typed already. Oh look, it inferred it automatically. Look at that. It returns the number. Nice. Okay, so functions as promises. So let's say async function get posts, all right, from a database or something. So there we go. So the way you do this is you say promise, and this is the generic that you pass it down. So basically what you're saying here is that when the promise resolved, it's going to return you this number. And then here, so we can do something like const post, right, is going to be equal to await, and then we can do something like set await new promise. We got the res here, and then we can say res, and then we can do what? Set timeout res 2000, and then we can return posts. Oh wait, I'm just saying a delay here. Hold on, that's stupid. I don't want the timeout. Wait, what did I have before? Oh, okay, because it's not returning a number. Have you tried the Vimium extensions? Yes, I did try it. I have it installed now. I'm still getting used to it. Here we go, look. See? I'm moving with the Vimium. Okay, so here we go. New promise. Res dot. That's confusing. Just want to return. There, right? Because I'm doing the top level away, right? That's why it's erroring out there. Okay, that works though. We got to see it. Okay, functions which return promises, anonymous functions. Anonymous functions are a little bit different from function declarations. When a function appears in a place where TypeScript can determine how it's going to be called, the parameters of the functions are automatically given types. Okay, so we have names here. Contextual typing for functions, parameter s is inferred. So let's see, yeah, here s gets inferred as a string. It knows the context. And it also works for arrow functions. Okay, good to know. Even though parameter s here didn't have a type annotation, so we didn't have to specify, hey, this is a type string, it deducted it. TypeScript did it. It knew that we were doing a for each loop, and it got it. Okay, object types. Apart from primitives, the most common sort of type you'll encounter is an object type. This refers to any JavaScript value with properties, which is almost all of them. To define an object type, we simply list its properties and their types. For example, here's a function that takes a point-like object. All right, so you got the point, all right, and then it's an object, but we specify in here that we have an x and y that are both numbers. So again, it can also infer it here because it has enough information, and there you go. Here we annotated the parameter of with x and y. Yep, okay. Optional properties. Okay, so if you want an optional property, you can add the question mark there. Or what you can also do is do string or undefined, where you can add a little slash. There's a difference between the two, but I cannot think of the difference. So let's give it a shot. So if I go here, I do function print name. Okay, so let's pass in an object here that's gonna be a first of string, right? That's obligatory, and last that can be optional. And then here, let's just return first plus last. Sorry, obj first plus obj last. Okay, so you get this. And now if you do print name, you can do first Bob. See how it doesn't error out? And that's because that's marked with a question mark. However, if I do that or undefined, now let's see what it says. So now it says last is missing in type but required. Okay. And the question mark back there. And then we can also set a default value if we want. So for example, print name. So if we save this, for example, here, name is equal to print name. Check this out, console log user name. There we go. So button run this, Bob undefined we get, right? And the reason why we get Bob undefined is because we never pass the second parameter, and it's also marked as optional, so it's going to default to that. Yeah, but we can come here, and for example, I can come here to the last. I can leave that as optional still, and set this equal to Lazar as the last name. Like Bob Lazar. With the aliens, you know him? What did I miss here? I'm not setting this correctly. Default value. We'll come back to it anyway. Okay. Anyway. Okay. Let's get to it. So we got union types as well. So TypeScript type system allows you to build new types out of existing ones using a large variety of operators. So the union type, the first way to combine types together is with this. So it's kind of like the or symbol, right? It's either a number or a string. Type 2 or more types representing values that may be any one of these types. We refer to each of these types as the union members. Okay, so we can say print ID is going to be either a number or a string. And then you can narrow it down further if you want to. So I can do something like function print ID. ID can be a name, sorry, a number or a string like that. And then here, if I say console log, sorry, let me just show you this. Columns my ID, I'll just set it equal to it, right? So it's a string or a number. And then here you can further say if my ID, sorry, what is it? Type of my ID triple equals to string. No, to number. Let's do this. If it triple equals to number, then what I can do is take, let's do let here as well, because I want to modify it. So up here, as you can see, it's string or number, but here I can say something like my ID equals to ID to string. So now my ID down here is only string, because we narrowed out. It's like deduction, right? You see kind of what you have. It can be either this or that. So you handle the case, and then it can only mean that it's a string now, right? Hello, hi everyone. I have a question, please guide me. I am developing UI for scripts for 5M. I haven't heard of that. I'm not sure what as. So I'm using React and Tailwind, but how can I make more optimized so it will be smooth in game? Oh my god. What does that mean? That feels like a ChatGPT question. The way it's typed out, sorry. Sorry. Yeah, let me know. I'm not sure. What do you think is the best way to use WebSockets with Expo and React Native for real-time SSD? What are you building? Okay, I'll have a look at this. Not now, but I'll have a look at this for next time. When you say learning everything about TS, you're going in deeper about it, or you're just starting now with it? Sorry, I might have, I should have probably changed the title a little bit. I'll change it to reading the entire Typescript Docs. That's probably more accurate to what we're reading, the entire Typescript Docs. So I'll update that title actually, and I'll update it on Twitch as well. There we go. Reading. There we go. But yeah, we're kind of learning and also catching small little things that we didn't know. So that's kind of the goal of this. What tools do you use for automation testing? I don't use any tools for automation testing. Who needs testing? I'm joking. I will need to write tests for my platform. I'm probably just going to be using Playwright. Okay, so let's see how much progress we made today. So we are here. We're almost 3 hours in the stream. We have loads more. So we'll finish this up, this section here, and then we'll hop on next time on the stream until we finish all this up. Okay, so type aliases, we did that. So here we go. So you got two things, right? You got type aliases and you got interfaces. There's some little differences between them. most importantly, interfaces are quite nice if you're like trying to extend a bunch. So maybe you have like a, a video, sorry, like imagine you're like Netflix or something. You have your chapters, right? And then you have videos. So you can imagine those two are two different interfaces. So you can say, hey, videos extends the chapters type, right? And then you can get all of that from there. Whereas it's a bit more complicated in TypeScript and less efficient as well. And sorry, not TypeScript, with types, if you're just using types and combining types together. Okay, so you just say type, and that's it. So you say type point, for example, here. There we go. And then you can just pass it down like that, the whole thing, the whole shebang. We know that. Everybody knows that. Good. We can go on. You can actually use a type alias to give a name to any type at all, not just an object type. For example, type alias can be a union type. Okay, so you can do something like this. So basically it's saying it doesn't need to be an object type like this. Type user, which is an object, right? We do the curly brackets and then we have a name of string and then we have an age of whatever number. All right. So what we can also do is go here and have a type of ID, like it says here, that's equal to either a number or a string. All right, there we go. And if we hover over this, there you go. Cool. Note that aliases are only aliases. You cannot use type aliases to create different distinct versions of the same type. When you use the alias, it's exactly as if you've written the alias type. In other words, this code might look illegal, but it's okay. Okay. So let's see this big illegal code. So type user input sanitized string. All right. And then here, what's it trying to say? Hold on. What was it trying to say? So we just have a type, which is a funny way of saying a string type, right? But super long. And then here we have a parameter that's type string. So what we're returning as well is a type string. User input can still be reassigned with string though. Okay. Hi, Piyush. How's it going? All right, interfaces. An interface declaration is another way to name an object type. All right, so it pretty much looks the same as up here. We just type more. We say interface. Just like when we used a type alias above, the example works just as if we had used the anonymous type object. All right, let's have a look at the differences. This is the exciting stuff, right? Here we go. So, adding new fields to an existing interface. So you have an interface window, title string, interface TS, all right. A type cannot be changed after being created. So you make it, and you cannot update it. Okay, so types cannot be updated. Okay, let's put everything to the test here. Okay, we got type user, right? And then I want to go type user name string. No bueno, not allowed. Duplicate identifier, not good. Okay. Okay, let's try with interface. Animal. We have a name. Okay. So then here, why is my Vimium not working? Well, how am I supposed to view that part of the website? Okay. So what we do here, so it's the same name, right? So how does this behave then? I actually haven't really known this about the interface that you can, so I can do the same name? Animal again? Holy shit, you can. Age? This is a fucking old animal, this one. It works. So then let's do this as a test. Monkey? Age 20. So then it's gonna get which type here? The age? Animal. Type number is not assignable to type. Oh, sorry. What am I doing? This is equal to an object. There. Age 20. Oh, that's to type 99. I meant the number, sorry. Okay. Name is missing, so is it just combining them together? You gotta be careful with this. Because then what if I make an interface with the same name, but you don't even realize it? Ooh, that's interesting. That could be very dangerous, hey? Hey, Roz, hey. Good to see you. Thank you for joining our streams. We're learning to type faster. We're going through the entire Typescript Docs in hopes of reading it and then getting better at it. So we covered a bunch of like the tsconfig rules, and we are currently maybe on chapter 2. We barely made any progress. Oh my god. But thanks for joining. I always wonder what's the differences between the types and interfaces. Okay, so that's one of the big differences. You cannot have the exact same name for the type, but you can have the exact same name for the interface. And then it's going to complain because it's going to combine them together, basically, by the looks of it. Okay. What else? What else is new with this? So, okay. You'll learn more about these concepts and later. You're not ready for these concepts now. Type aliases may not participate in declaration merging, but interfaces can. All right, yeah, we saw that. Here we go. Interface names will always appear in the original form in error messages, but only when they are used by name. What? What do you mean? Using interface with extends can often be more performant for the compiler. Here's what I was talking about. Then type aliases with intersections. Okay, so when you do, type this, and then you do and, I also got the type of other type. Sorry. How'd I do the thing? How'd I do the thing? Chat. Oh, sorry, not like that, right? You'd add, because that's one type, and then you and then you can add another type here. Let me try it, because I don't know. Type Snooky. It's a Snooky type. Jersey, Shore, Boolean, and that's true. And Snooky. One and symbol. Okay, so doing this is gonna be much slower. Type test. User type. Oh. Okay, fine. Let's define all of this. Oh, we did age, name, snook. What else we have? Jersey Shore, true. Okay, so this will be much slower than doing something like this. Snooky. Duplicate identifier. Okay, snooks. Interface snook. And then this will be interface user. So now here you do something like interface user extends intersnook. And now this, will that work then? Enter user. Now this should expect name, cool. And, well, let's have it the same, right? Oh yeah, okay, cool, yeah, that works. There you go. Okay. So if you have a bunch like mixing stuff together, go with extends. I guess if you have like small types, it wouldn't really make a like performance difference if you're doing any type merging or stuff like that. Maybe set shift width to 4 in envim. Okay. Shift width. That work? I'm not seeing anything. Okay, anyway. Yeah, let me know. What am I doing? I'm doing something wrong, am I? I won't be 8 right away. I'll keep an eye. Okay, type assertions. Sometimes you will have information about what does it even do. Hold on. Okay, let me shift width in NeoVim. So how much? Oh my god, what do I have that set to? Set shift width 2. There we go. Goodness, that was horrible. 2 spaces. What are we doing? 2 or 4 spaces? Chat. 2 or 4. Which one's better? Did you look at generics? No, we're still at the beginning of this. We'll probably get there the next time. 2 always? Yeah, 2, right? 2 looks better. Let's see. Shift, set, shift, width, 4. That's too much. No, that doesn't look good. Set, shift, width, 2. Yes. W's. Thank you. David, I appreciate you. Okay, what are type assertions? Do you guys know? Sometimes you will have information about the type of a value that TypeScript can know about. For example, if you're using document.getElementBy, TypeScript only knows that this will return some kind of HTML element. But you might know that your page will always have a HTML canvas element with a given ID. So in the situation, you can use a type assertion to specify a more specific type. All right, so when you're calling document.getElementById, you can say as canvas element or whatever. And you're gonna see this a lot in like Like here, for example, like if I go to my card, right? So this is like some kind of like assertion here, right? You have a card that you want to use, kind of like in ShadCN. If you used ShadCN before, it's just a div, but you want to make sure that you pass the correct type so you can like forward the class names through props and everything else. So you specify this as a type of React.component props, and then the generic that you pass it in is going to be a div, right? So that's kind of how it is. You might have something like this that's maybe a bit more specific. For example, here, this is a component that has, it's basically, it has the props, but you just don't get the ref. So you can do component props without any refs as well. You might have a handle mouse move, for example. Then that's a React mouse event, and then you can pass it in. You can pass in the generic as well here. That's a div element, and you can do it for pretty much anything that you wish out there. For example, here I believe I use motion in one of my packages here as well. I swear I did something. Let me see if I can show you motion. Here, for example, so let's say you want to do breadcrumbs in ShadCN, right? I'm using motion here as in framer motion. So the props are not going to be HTML props anymore. It's going to be HTML motion props. So this is a specific type that's imported from the package. But the more you play around with this, the easier it usually tends to get. Okay, so that's essentially what it's trying to say here. Reminder, because type assertions are removed at compile time. There is no runtime checking associated with type insertions. There won't be any exception or null generated if the type assertion is wrong. So TypeScript only allows type assertions which convert to a more specific or less specific version of a type. This rule prevents impossible coercions like this, right? So if you do hello, you can say as a number. And in this case, that's like an impossible thing to do. Sometimes this rule can be too conservative and will disallow more complex coercions that might be valid. If this happens, you can use the to assertions first to any or unknown, which we'll introduce later. Okay, so we'll have a look at this later as well. All right, literal types. In addition to general types like strings and numbers, we can refer to specific strings and numbers in type positions. So one way to think of it is to consider how JavaScript comes with different ways to declare variables. Both var and let allow for changing what it's held inside the variable, and const does not. This is reflected to how TypeScript creates types for literals. And that's how it's literally the thing, right? So that's what literal type is. If I have something like a type of actually literal, that's okay. So look at this. So this is gonna have a name on it, and it's me. Now here's the thing. If I do a test here and I explicitly say, hey, this is an actual literal type, right? And I have a name on this, and if I do woo, see, it can be woo. So it's not that it's a string. It's literally the text that's in there that's me. And that's the only value you can accept and nothing else. So woo is not assignable to type me. So it has to be me. Otherwise it won't work. And same for a number, right? So if I have a price here, for example, I can do number, right? So if I have number there, I can pass in a price of 20, right? That's fine. No problem. Pass in 50, right? Pass in minus $2 trillion. No problem. But a literal type is going to be the exact value. So if I do 50 here, then price is not going to accept anything other than 50. And you get a nice autocomplete as well, so you can see, hey, look, 50. Without plugins and editor config, it'll be 8 by default. Oh, I need to set that in my NeoVim config to be 2 by default. Okay, let's wrap this up. We're almost at the end of part 2 of chapter 2. All right, literal types. So we saw this. Everything is clear. Hopefully everything is clear. It's not much use to have a variable that can only have one value, but by combining literals into unions, you can express a much more useful concept. So this is fantastic if you want to have, imagine you have like a website, right? And you have maybe different kind of privileges that you give. So you can have maybe this user is a type of admin, this user is a type of basic, you know, or he's on the pro plan. So you can create these union types of the literals. So you can do something like this. We can do type of rights or access. Type access. And type access equals, it's either admin, it's either pleb, or he's on the pro plan. There we go. So now when I make a user here and I say, hey, this is type access. Let me just do T, okay? Is it fine? T access, is that clear enough? That's how I usually like to do it anyway. So check this out. Look, boom. It can only be these 3 types. So this is where literal types actually become a bit more useful, because you got that. Okay, and then you can do the same numeric literal types work the same way. So there you go. Of course, you can combine these with non-literal types as well. So interface, let's see what we have here. Options, width of number. And then we have a function here that takes in the options, or it can also switch to auto. So it says argument of type automatic is not assignable to parameter of type options and auto. Okay, yeah. So you can combine them. It's not like you use literal types and then you cannot combine them with anything else. It's still gonna work. Not sure why you would want to use it this way though. I would probably not do it this way. You probably just have it all in the interface. There's one more kind of literal type. It's the Boolean literal. So there are only 2 Boolean literal types. So it can only be true or false, right? That makes sense. So the type Boolean itself is just an alias for a union of true or false, right? So it is only those 2 values. Literal inference, when you initialize a variable with an object, TypeScript assumes that the properties of that object might change values later. For example, if you wrote code like this. What is it? What is it trying to say? Let me type it out so I can realize it myself as well. Counter. See, okay, so we have an object with a counter 0. If some condition, then what? Then object counter equals 1. So TypeScript doesn't assume the assignment of 1 to a field which previously had 0 is an error. Another way of saying that this is that object counter must have the type number and not 0. Okay. Because types are used to determine both reading and writing behavior. The same applies to strings. Okay. Okay, cool. So here as well, right? You do URL string method of get and post, returns nothing. And here you get argument of type string is not assignable to parameter of type get and post. Right? We're trying to pass request method here, which is a string. So it's not good enough, right? It says no, it has to be get or post. I know it might be a string. No bueno. Okay, there we go. And the above method, here we go, request method is inferred to be a string and not get. All right, so it doesn't get that precise thing, the actual precise like get text, because code can be evaluated between the creation of request and the call of handle request, which could assign a new string like get, right? So request method can change in terms of like what kind of string it actually has in there. So TypeScript, so if it doesn't know exactly, that's gonna start generalizing a bit and it's gonna say, hey, it's a string. So there's two ways to work around this. So here we go, you can either one change this. So the method is a type of get, or you can say as get like that. Here we go. Like this, right? So you say it's get. So change one here. I intend for a request method to always have the literal type get. All right, so it can always be get, preventing the possible assignment of guess, for example. Change two means I know for other reasons that request method has the value of get. You can use asconst to convert the entire object to type literals. And this is probably the best thing, and we'll get back to this in the future as well. Asconst is a fantastic way of just declaring the whole thing as a literal type. And what's nice about asconst is if you have an object, so if you have something like this, right? So you have age, 20, name, woo, okay? But you might have maybe a category here. And this has a bunch of other stuff in here. If you do asconst, even the sub values here are gonna get read-only. Is there a way to constrain the value to be less or greater than something in literal context? Let me try to think about that. What's the use case for literal types? So like in what case would I need this? You would use it in the context of actually like putting a couple together, right? So again, like something like this. You have like a plan, a T plan, right? And then you have free. So this would be a literal type, right? A free. Let me do it all uppercase. Right? So we got 3 literal types, and we're doing a union between all of them. That's all we're doing. And now, what is that doing now? And now, so we have a user, right, with the T plan, then that can only be these 3 values. So I cannot do something like undefined, for example, right? Not assignable, not assignable, not assignable, right? It has to be those 3. And then as for something like type child age is less than 80. So when you have const child age, it will show the compile time child cannot be. Oh, I see what you mean. I don't think you can. No, I don't think you cannot have. So you cannot have something like this. You cannot have type. Let me show you your example then. Type child, right? You said, and that's equal to. So here, age. I cannot pass anything like that. That stuff like that's not gonna work. This is only gonna take in a type. So whether that's and it's literally only 2 things you can add here. So you can only add either a literal type, so like 20, or you can add a more general one, like number. But what you could do, I guess you could get, if you want to do something like type child age is yeah, you wouldn't be able to do that, would you? Test age, so you could do this as a child, right? Well, I'm just having to think about this because it's interesting. That would be a cool, that's actually a good point, you know? But wouldn't be able to do that, would it? Because by the time the code runs, so that's the thing. When this actually gets executed, these would get stripped out. So there would be no way for TypeScript to know if the value is like bigger or lower than 50 here. Because remember, when this code actually runs, this turns into this. Right? So then the only real way where you could do the check here is if you make some sort of function, right? Do a JavaScript's functional anyway, right? So you'd want to do something like const check age is like 50, right? Is big. And then you have your function here, so which takes an age, that's a number, and then you do the narrowing here. If age is bigger than 50, then you do whatever to this, right? It'll be able to run only in const context. Something like const child equals array. Yeah. I see what you mean. Do you know this type T? Okay, what's this? Let me have a look at this. Okay. So type T, which is a type of typist, so that's a literal type or a literal type of this, or a string and an MD object as const. What's this here? This I might have. Hold on, let me separate this. Okay, so you here is a type of T. Okay, so this essentially gives you the ability to do what, right? You can pass in anything else as well. Is that what you're trying to say? This should work without that as well, right? Like that, yeah. Okay. The sample from Aurelian is something he learned from one of the last videos of Matt Bocock. How about you do a union type from 1 until 18, then do extract the type. Okay. Well, we'll get to all of that. We're still at the beginning. Don't worry, guys. We'll wrap up this section, and then I'll be back either tomorrow or the next day, and we'll pick up from here, and then we can answer all of these questions. Okay, let's wrap this up. So, because I want to have a look more into this as const as well. We'll pay more attention. So null and undefined. JavaScript has two primitive types. Values used to signal absence of uninitialized values. So null and undefined. So when you create a variable, right, let name, right, by default, that's going to be initialized with undefined. And null, TypeScript has two. This represents a lack of value, right? TypeScript has two corresponding types by the same name. Strict null check, so we've done that. So we won't spend too much time on that. There we go. Yeah. Okay, cool. None null assertion operator. So TypeScript allows a special syntax for removing the null and undefined from the type without actually doing any explicit checking by writing the dollar sign, sorry, not the dollar sign, the exclamation mark. So you've probably seen this a lot, right? So in this project, for example, as well, if I want to do something like here's an example. Off. Right? If I do something like this, this could be undefined as well. So it's either a string or undefined, C string or undefined. So then you add the banger symbol like that. Or you can also do as string as well. That would do it as well. Okay. And then here again, you can check as well. You can say if x equals null, then you can catch that. Enums, we're going to talk about this more because enums are quite special in the sense of like TypeScript usually is just types, right? But enums actually, when you compile enums, they actually leave you some code. They actually generate code, believe it or not. Okay, and then let's have a quick look here and just wrap this up. Less common primitives. So big int, since ES 2020 has been added. So there you go. You can do a big int for the type, and then you can do a big int as well, like that. And then the symbol as well, right? So you can do symbol, name, like that. So there's a primitive. Okay, like that, and that gives us the type of, okay, cool. This comparison appears to be unintentional because the type of first name and type of last name have no overlap. All right, there we go. Look, and then we're gonna get into narrowing and some other stuff like that and generics. We're gonna leave it here. Again, we're gonna talk about more about enums and stuff like that. I'll go have a rest. I'll hop onto building the platform out, and then I'll probably finish up the night with playing some Expedition 33. I've made some good progress. I'm almost through the entire game. I wonder where I even am. You sound like PewDiePie a bit. Not gonna. I don't know why. I don't know why people keep saying this. You know what's funny? I posted a little thing on Reddit. Because I was doing like a NeoVim thing, right? And guess what the most upvoted bloody comment was? Or at least one of the most upvoted comments was? Here, I posted this video. Where was it? Hey, Pewds. Why? See? I don't know why. All right. Thank you, everyone, so much for joining me. Hope you enjoyed this little session. We're going to keep at it. So make sure you are subscribed to this channel. Make sure you are following. And we'll pick it back up. And yeah. Catch you in the next one. Nighty night.